All right, so this is actually part 3, finishing up here even in the middle of question 9 on this Cramer's rule question. Again, just making some numbers up here, so we're looking mainly at the process. So as I look at solving for y, what we've done is we've substituted our solutions in for y. That's your 7 and negative 11. We're going to find a determinant. Okay, so we have negative 3 times negative 11 minus 6 times 7. We know that our lower determinant is negative 3 from what we've done before. Okay, we know that negative 3 times negative 11 is going to be 33 minus, we just have 6 times 7, so it should be what, 42? So 42 over negative 3, we have 33 minus 42, which is negative 9, divided by negative 3. So y equals positive 3. So if we scroll back up here, we see that x equaled 2/3, y equaled 3. And that's our process for that. So if you're lost in all that, go back, watch video 2, go down to the end of it, and you'll be able to see what we're talking about here. We'll pick it up, question 10, and we'll just go until we're done here. All right, so we want to know what the solutions are for something like 4x minus 10, absolute value of 4x minus 10 minus 4. Let's see, we're going to set that equal to negative 2. Okay, so remember the very first thing we have to do is isolate the absolute value. So we're going to add 4 to both sides. So before you get too worried about an absolute value equaling a negative, we see that absolute value of 4x minus 10 actually equals 2, so that's not a problem. Now we have to find both solutions. So we're going to say 4x minus 10 outside of the absolute equals positive 2, and 4x minus 10 equals negative 2. And then solve for both of those. Okay, so we're going to add 10 here to both sides. We got 4x equals 12, divide by 4, x equals 3. Okay, over here, add 10, 4x equals 8, divide by 4, x equals 2. So it equals, x equals 3 or 2. Okay, so again, we're looking at the process here. Don't memorize the problem, memorize the process. 11. Let's see if we can get here. Okay, we have a conversion. We want to convert 100 meters per second, okay, into kilometers per hour. Okay, so we're going to rewrite it. We got 100 meters over 1 second. Let's go ahead and convert meters to kilometers. I want my meters on the bottom so that they cancel out. I need kilometers on top. A meter is smaller than a kilometer, so kilometer gets 1, and there are 1,000 meters in a kilometer. Now we need to convert seconds to hours. Okay, we'll put seconds on top, hours on the bottom. Hours are longer, so they get the 1. And there's 60 seconds in a minute, 60 minutes in an hour. 60 times 60 is 3,600. So we get 3,600 on top. So now with the calculator, we have 100 times 3,600, which is 360,000. Okay, over 1,000. Okay, so we can divide 360,000 by 1,000, and we get 360 kilometers per hour. Okay, 100 meters per second is 360 kilometers per hour. Okay, we want to find an expression. Find an expression that converts 20 feet per second into miles per hour. Okay, so we would start off by writing 20 feet over 1 second. Okay, we want to convert feet to miles, so feet are going to come down here because it's on the top over on the other part. Miles on top, miles are bigger, 5,280 feet in a mile. Okay, and now we want to convert seconds to hours, so just like what we did in the other part. Seconds here, hours here, 1 goes down there, 3,600 up here. And what they're actually looking for is they're not looking for the solution, they just want to know the minimum that we need to see out of this. And so that would be 20 times 3,600 divided by 5,280. Okay, and we would get a miles per hour. So we'd see something like this. Okay, so this is actually our answer. We want to know what is the conversion that will get that for me. Okay, number 13. Okay, we're going to get something along the lines of x plus 3 times x minus 6 times x plus 5. And we want to multiply. That's going to be our instruction, is multiply. Okay, so we're actually going to do FOIL a few times here. So what I'm going to do is I'm going to do the leftmost pair. Now you can do the rightmost pair, it won't matter, but we're going to do the leftmost pair here. So we're going to do FOIL, first, outer, inner, last. So I'll put that little FOIL, okay, just as a reminder. So x times x is x squared, x times negative 6 is negative 6x, 3 times x is positive 3x, and 3 times negative 6 is negative 18. We're going to go ahead and we're going to simplify by combining these two like terms. So we're going to get x squared minus 3x minus 18. That can't be simplified any further. So now we're going to bring down this x plus 5. Okay, and now we're going to distribute the x and the 5 to all the terms in the left. So here, here, and here to start with. So we've got x cubed minus 3x squared minus 18x. Now we're going to do the same thing with 5. Okay, so 5 times x squared is positive 5x squared. 5 times negative 3 is negative 15 with an x. And then we have 5 times negative 18, which is negative 90. Now finally what we want to do is we want to combine our like terms. We only have 1x cubed, so we can take that. We've finished off that. Okay, we've got a negative 3x squared and a positive 5x squared. So that's going to be positive 2x squared. Okay, we have a negative 18x and a negative 15x. So negative 18 minus 15 is negative 33x, and then 90 our negative 90 has no like terms. It's just left to itself, right, like what we see here. And this is our final answer for that work. So you FOIL, and then you FOIL again. Okay? 14. Okay? We're going to do something along the lines of f of g of negative 4, provided that f of x is equal to, let's say, negative 2x plus 8, and g of x is equal to, we'll say, 2x plus 7. Okay, so there's a couple different ways to do this. We can plug in negative 4 for x in both equations first, then multiply, or we can multiply them, then plug in negative 4 for x. I prefer to go ahead and plug it in at the beginning. So we have negative 2 times negative 4 plus 8, and we have 2 times negative 4 plus 7. And then we'll multiply those solutions. So follow order of operations. Negative 2 times negative 4 is positive 8. 8 plus 8 is 16. 2 times negative 4 is negative 8. Okay. Plus 7 gets me an answer of negative 1. Okay. 16 times negative 1 is just simply negative 16. And that's a lot easier than solving algebraically. I think that'll be the fastest way for you guys to get to your answer. Now, it says that this can be a negative integer, so therefore it's accepted in this case. Okay, but if it says that the domain has to be positive integers, that would not have worked. Okay, this is a question here on 15. It's probably not one that you've seen a lot of, where it says f of x, and it gives you some parameters. Okay, say something like 3x plus 8, x squared minus, say 7, and 24. Okay, they'll say if x is less than or equal to negative 5, if negative 5 is less than x and less than positive 5, greater than negative 5, less than 5, and if x is greater than or equal to 5. Okay, so we want to look at things that will work here. It says then, so it gives you all that. Okay, it says then f of negative 8 equals. Okay, so it gives you all that. All right. So what you go about doing is you start plugging negative 8 in for x into these different scenarios to see what you would actually get. Okay, and then the one that works is the one that you actually plug in either over here, here, or here to see what it equals. So on our first one, okay, this one right here, okay, 1. Okay, we're going to say 3 times negative 8 plus 8. Okay, well 3 times negative 8, okay, is negative 24, plus 8, okay, is negative 16. All right, is negative 16 less than or equal to negative 5? Okay, well, negative 16 is less than negative 5. So it appears so far that this works. Okay, we'll come back to that in a second. All right, for 2. Okay. Okay, we'll look at 2, and if we would plug in negative 8 squared minus 7. Okay, well, negative 8 times negative 8 is 64, minus 7 is 57. Okay, so come back up here and look at the parameters. Is that less than 5 or greater than negative 5? Well, it's greater than negative 5, but it's not less than 5. Okay, so we don't end up using this, okay, because it's not true here. Okay, then we come down to our final part, okay, our part 3, okay. Okay, so we do negative 8, and we just plug it in for x. Is that greater than or equal to 5? Well, no, it's not. So we don't use this or this. So we come back up to this number 1 spot, okay? We look at this. This was correct. 3x plus 8 worked because when we got our answer, it worked here, okay? Okay, because we see that in our solution right here. So our answer is negative 16. So that's somewhat of a difficult question because basically you're looking at this right here. You're plugging it in for all of the x values. Here, let's use a different color. X value here, x value here, okay? And essentially kind of just the x value here, okay? And after I've plugged it in, do these work? Okay? And whichever one works, we come back to these sets here, here, and in this case here, plug it in and say, that's our answer. So I know it looks like a crazy mess. That's what that question is looking for. Okay, 16. Okay, 16, we're evaluating, so we should get an answer. Okay, we're going to take something like 4 plus 6 into the 4th if n equals 3. Okay, so all we do in this is just plug in. So we get 4 plus 6 times 3 to the 4th. Okay, so the very first thing is order of operations. We're going to find out what 3 to the 4th is, or 3 times 3 times 3 times 3. It is absolutely not 12. 4 plus 6 times 3 to the 4th. 3 to the 4th is 81. Okay, now times 6. Okay, so we get 4 plus 486 plus 4. We should get an answer of 490. That's it right there. Okay, plug in into the equation, or 3 in this case, and solve. 17. Okay, 17, we just simply want to simplify. So we're going to get something along the lines of like a to the 6th to the, let's say, negative 9th. And then a to the 5th. Okay, so I'm using power rule of exponents here, so I'm going to multiply 6 times negative 9. Okay, 6 times negative 9. 6 times negative 9. Okay, we get a to the negative 54 power. And in here, I have a to the 5th. Here, I'm taking negative 54 plus 5. Okay, that is giving me an answer of negative 49. That's giving me a to the negative 49th. Okay, so my final answer, I want positive exponents, so I'm going to drop a down, and I'm going to get a 1 over a to the positive 49th. Okay, a lot of people get this question wrong because they don't multiply and then add and then drop. Multiply, add, and drop. Okay, this is our answer right here. 18. 18 is going to deal, it's kind of a word problem. So we'll take something like 4.87 times 10 to the 23rd. Okay, we're going to say 4.87 times 10 to the 23rd atoms in 1 gram of oxygen. Again, my numbers have changed here a little bit. We want to know how many atoms are there in 700 grams of oxygen. Okay, we want our answer in scientific notation. We want to round our answer to 2 decimal places. Okay, so in 700 grams of oxygen. Okay, we want our answer in scientific notation. Well, if there's 4.87 times 10 to the 23rd atoms in 1 gram, we should be multiplying here. Okay, so we're looking at something like 4.87 times 10 to the 23rd, okay, times 700. Okay, but what I want to do with 700 is I want to convert 700 over to scientific notation. So that would just be 7 times 10. But 7 times 10 is just 70. All right, I need 7 times 10 to a power that's going to be equal to 100. So 7 times 100. So I need something 10 to a power that's going to make 10 equal to 100. And that would be 10 squared. 10 times 10 is 100. 7 times 100 is 700. So we want to look at something like that. Now, you can very easily know that we're going to take our 10 here and our 10 here. We're multiplying those things, and so we can add their exponents. So that's going to be 10 to the 25th. Okay, so that's our first part. The next part I'm going to do is I'm going to take my calculator and do 4.87 times 7, okay, which gives me 34.09. The problem is that that's not in scientific notation. Okay? So what we do with that is we need to move this decimal place 1 place to the left. 1 place to the left. We need to get 3.4, we could round it up to 1 times 10 to a power. Okay? 3.41, okay, in replacing of 09. All right, as we move to the left, normally we think as we move to the left that we subtract, but in this case we actually add. Okay, so it's 25 plus 1. And I can double check. All right, I'm going to take my calculator, 34.09 times 10 to the 25th. Okay, and it shows me in my calculator actually as I type it, it changes it to scientific notation where it shows me 3.409 E26. That E stands for times 10 to the 26th power. So I know, okay, that we've done that right. So as we move the decimal point to the left, we add. As I move the decimal point to the right, we subtract from our exponent. Okay? If that helps. As you move the decimal point left or right, you see on the top exponent either adds or subtracts. So that's not a bad little thing to add to your notes right there. Just kind of help you remember what to do. And so we only moved it once, so we only added 1. All right, I believe we're ready for, let's see, number 19. Number 19. Okay, number 19, they're going to show you a list of graphs. You need to determine which is a function. So if we have something, we'll look at a handful. Okay. Okay, look at this, look at that. Let's see what others. They give you some kind of different ones, and I think you guys have seen these all before. Something like this. Okay, something like that. Okay, I'm going to use a blue line to be my vertical line. Okay, you can draw multiple lines if you need to, but I'm looking at how many times it crosses. Right here, it crosses it twice, crosses it once, crosses it twice, crosses it twice. Okay, if I can draw a line that will cross anywhere on there, okay, more than once, then it is not a function. Okay, not. Okay, this is a function. It passes the vertical line test. That's what we're looking for on 19. Can I identify a function by its appearance? 20. Last question should be, okay, price of a train ticket. Price of a train ticket is normally $115. Okay, again, this is where you need to listen. However, if you've got kids under the age of 15, there is a 65% discount. Under 15 years old, get a 15% discount. Okay? We want to find the sale price for someone under the age of 15. How much does it cost them? So we're going to take $115. Okay? We're going to find out what 15% of 115 is. So 115 times 0.15 is equal to $17.25. Now that's not how much they pay. That's how much we deduct. Okay, so we take 115 and we subtract 17.25. Okay, 115 minus $17.25, and they are going to pay $97.75 for the train ticket. All right. Hopefully that helps. Hopefully that gets you ready. Let me see. Okay. All right. I think we'll stop it right there.